By using reinforcement learning with a spatial LSTM network, the agent learns the policy based on the reward function, which suggests a certain action at a specific point of time. The model is composed of a reinforcement learning technique with a spatial recurrent neural net. I add a spatial dimension to a recurrent neural net to process multi-level sequential data. If the agent has prior knowledge, it is favorable. The agent could know how this semantic net is structured. The agent could also possess knowledge of logical statements and their truth values. But this is not required. By using reinforcement learning with a spatial LSTM network, the agent learns the policy based on the reward function, which suggests a certain action at a specific point of time. The input consists of operators and variables, including their truth values and time steps. The truth values referring to the variables or numbers or words can be fuzzy values or values of modal logic. The creator agent chooses the numbers or variables and the operators in an alternating way to create a logical statement. If the agent compares equivalent statements, it uses the AND operator. If both statements are true, both statements are equivalent. The truth value of the entire statement is 1. If one of the statements, or if both statements are false, the truth value of the entire statement is false. The truth value is 0. At each time step, a logician observes the current state of a statement and chooses the truth value according to the policy. The agent maximizes the cumulated reward. The spatial LSTM solves the partially observable Markov decision process. The procedure relates logical statements. Logical statements are sequential data with a temporal dimension. The comparison of multiple statements is a parallel process. If one ID is the generic term, its position is above the other. If two ideas are equivalent, they are at the same level. These ideas are 2D ideas. I add a temporal dimension and they become 2 plus 1D ideas. I assign coordinates to each 2 plus 1D idea. I calculate the position of the ideas and integrate the function into a formula. I add an interaction value. I use the spatial LSTM to process the input tensor and to predict whether created statements are true or false. The context information approaches a position from 6 directions which I relate to the gates of the spatial LSTM network. The LSTM unit is composed of a cell, an input gate, an output gate and a forget gate which process the flow of information. I use this procedure to prove logical theorems by using inference rules which determine the truth of the theorem. A logical axiom is a well-formed formula which is logically valid. By using reasoning techniques, I deduce logically valid formulas or theorems based on the axiom.